All right. Um, we're progressively getting to more advanced methods of factoring because there will be, you know, more complex polynomials to try and factor. Okay, they can pose more problems and cause the other factoring methods to fail. So again, we're looking at trinomial factoring, but this is the case where the leading coefficient is not one. So if you remember the previous factoring methods we've looked at, the leading coefficient was one. But what do you do if it's not? Okay. So again, you're going to have a trinomial in this form, but because a is not equal to one, then you're going to have some kind of coefficient, in front of that leading term or leading coefficient. So what do you do? So like what we did previously is we looked at factors of the constant term, and we found two. We're also going to do the same thing by looking at factors of the leading coefficient. And we're going to once we got these factors set up for the leading coefficient A and the constant term C, what we're going to do is just go ahead and set up the product of two expressions like this. Right? Where J and K become the two terms here with X, and L and M become the constant terms in these two expressions here and here. And somewhat similar to the previous factoring method, what we're going to be doing is multiplying the two inner terms and multiplying the two outer terms and adding those together and see whether they are equal to the middle term in our original trinomial. And if that does not work, we will do the same process, but we'll switch the position of L and M. You can see that down here, and do the same process. So maybe I should have put that down there like so. Okay. So let's take a look at an example here. Okay. So we have 6x squared minus 11x minus 10. You'll notice that the leading coefficient here is not 1. So what we want to do is look at factors that'll give us negative 10. And we want two factors that'll give us a positive 6. So we could have, here, let me use different colors. I think that'll help. Okay. We could have a positive 3 and a positive 2, and a positive 2 and a negative 5. Now, okay, let's dispel with the mystery here. I mean, I could have chosen negative 3, negative 2. Okay, but that's going to not up being right. This is a trial and error process, and we could have also looked at something like this. Okay, but that's not going to work here either. And the only way that you know something's going to work is you just have to try different iterations of it. All right. Okay, so this factor of 3 or 2 for the leading coefficient, that'll become the x terms in these two expressions that we're going to be making the product of. And then the factors of the constant term, they will become the constants in each expression in the product of the expressions down here, down below. And what we do is you multiply the inners. So this will be 2 times 2x, that's 4x. And we add that to the product of the outers. So we have 3x times minus 5, which will be minus 15x. And that'll give us negative 11x. And this negative 11x is the middle term. So this is the correct factorization for this trinomial. All right, the next one is a think, pair, share. Try this one on your own. I've got the answer down here down below. So if you want to pause now, try it. I'll go ahead and give the solution here. So again, we've got a leading coefficient that is not 1. So we need to look at factors of 18. Now, again, we could have like 1 and 18. We could have 2 and 9, and we could have 3 and 6 with negatives of both. Okay. The one that's going to work is going to be 2 and 9 here. And then for 15, we could have 1 times 15, both negative, both positive, or 3 and 5, both negative and both positive. I'm going to use both negative. It's like, okay, well, Dr. Morales, how did you know both negative instead of both positive? Because I worked this out ahead of time, and this is what's going to work. So you just have to do it by trial and error, and you'll find the one that works. Okay, so the factors of our leading coefficient become the terms with x in each expression, like that. And again, let me use a different color here because that'll help kind of map this out. All right, so we're going to have negative 3 and negative 5 like that. So now let's go ahead and look at these inner terms. So we've got negative 27x, and then here we've got negative 10x. Oh, this is an x and a y. Okay, so I need to throw in an extra y here, like that and like that. There we go. Okay, and that gives us a negative 37xy. So this will be the correct factorization for this one. I said earlier, like I just, trial and error, that these were both negative, but I just remembered something. What I just remembered is that, again, we're going to be taking the product, of the inner terms and of the outer terms and adding them together. So because these two are both positive, the next two have to be both negative, and to produce negative products, that'll add up to a negative number up here. So that actually kind of gives me the hint that these two should be negative 3 and negative 5 instead of positive 3 and positive 5. All right, but if you're not very keen on this, if you don't remember this very well, or you're just relearning this and it's been a while, that'll be maybe a difficult thing to remember. Instead, just do trial and error. Instead of negative 3, negative 5, try positive 3 and positive 5, and see if the adding of the inner and outer products gives you this middle term or not. Okay, let me know if you have any questions.